NVIDIA is now a massive, multi-trillion-dollar corporation with a market capitalization that recently surpassed the gross domestic product of nations like Russia and South Korea. The company is widely categorized as a physical hardware manufacturer, a designer of the silicon powering the world's computers. This valuation is underpinned by proprietary software distributed for free, a codebase that effectively locked the technology sector into a single ecosystem. To comprehend how a 1990s video game component supplier conquered the future of global computing, we have to look past the physical chips and examine this invisible software moat. In the 1990s, NVIDIA focused exclusively on designing graphics processing units, or GPUs, for the PC gaming market. A standard central processing unit, or CPU, works like a single soldier solving one complex problem at a time. A GPU acts as an army of thousands, solving tiny mathematical problems simultaneously through parallel processing. Manufacturing these chips requires massive capital expenditures. The high-tech fabrication facilities needed to print semiconductors cost billions to build, which forced NVIDIA to outsource physical production just to survive. Relying on hardware meant weathering the boom and bust cycles of gaming and cryptocurrency mining, creating extreme revenue volatility that left the company vulnerable to market shifts. Selling physical silicon is a commoditized business. To build a lasting monopoly, NVIDIA needed a way to make their specific architecture essential to the software itself. In 2006, academic researchers began hacking into NVIDIA's gaming GPUs. They were looking for a way to use the thousands of tiny processors to run complex scientific and mathematical simulations. NVIDIA responded by creating CUDA, a proprietary software platform that allowed developers to write standard code for GPU parallel processing without needing to understand the underlying graphics hardware. CEO Jensen Huang pivoted the company's entire research and development budget to support this new computing stack, taking a massive risk on a market that didn't yet exist. Financial analysts rejected the strategy. For a full decade, Wall Street valued the massive CUDA investment at $0, seeing it as a drain on the profitable hardware business. NVIDIA was spending billions building a software ecosystem for an industry that remained purely theoretical. It was a classic platform gamble. The payoff arrived in 2012 with the AlexNet breakthrough. Researchers discovered that training deep neural networks required the exact type of massive parallel processing found in gaming GPUs. The mathematical architecture needed to render three-dimensional video game pixels turned out to be precisely the architecture needed to train artificial intelligence. The global AI research community standardized on the CUDA platform because it was the only functional software that made coding these massive networks feasible. Code written using NVIDIA's CUDA language is proprietary. Because these software instructions are hardware-specific, AI models developed on this platform cannot physically execute on chips made by Intel or AMD. By solving the programming problem for early researchers, NVIDIA became the underlying operating system for the entire field of AI. That decade of $0 valuation had secured a market position that raw performance could not overcome. Competitors could build a faster chip, but they could not easily migrate the industry's existing library of CUDA-based code. During the generative AI inflection point, tech giants were forced to buy NVIDIA hardware. Their developers already knew CUDA, making it the only viable path to building models like ChatGPT. This lock-in allowed NVIDIA to evolve from selling $300 graphics components to selling entire computing ecosystems. Through the acquisition of networking companies like Mellanox, NVIDIA gained the ability to connect thousands of GPUs without data bottlenecks that plague standard servers. Their modern business is built around selling AI factories, DGX supercomputer servers, where the hardware, the networking, and the software are pre-integrated. Controlling every layer of the stack allows NVIDIA to command profit margins that are unprecedented in the history of semiconductor manufacturing. Today, companies like Microsoft and Google are pouring billions of dollars into designing custom AI chips to break this monopoly. But a superior physical chip is useless if the world's developers lack the software ecosystem to run their models on it. NVIDIA reached its multi-trillion-dollar scale by controlling the software environment first. While competitors spent years trying to build a faster car, NVIDIA spent that time paving the only roads those cars are allowed to drive on.